We are still working on word problems that use systems of equations. So let's continue our practice. Day 3 was about the same thing. So if you need more practice on using systems of equations to solve word problems, see day 3 as well. Anyway, let's get started. The larger of two numbers is one more than twice the smaller number. The sum of the numbers is 20 less than 3 times the larger number. Find the numbers. This last statement tells us what the variables need to be. Find the numbers. So let's define our variables. Let's see, the numbers. Larger, smaller. So I'm just going to go in order. I'm going to let x be the larger number. All right, and I'm going to let y be the smaller number. Okay, now with that in mind, I need to now make my equations. Here comes the first equation. The larger of the two numbers is one more than twice the smaller number. So I'm going to get an equation out of this. Whoa. I'm going to get an equation out of this first sentence. So the larger of the two numbers is, we just said that x was the larger number. So x equals one more than twice the smaller number. So that's twice the smaller number plus 1. Boom! This is the equation that matches that sentence. So far, so good. Now let's do the next one. So the next sentence, the sum of the numbers is 20 less than 3 times the larger number. So here's an equation from that. The sum of the numbers, okay, that would be x plus y, because that's the sum, is equals 20 less than. Now I'm not going to start writing 20 because when you're subtracting you put it on the end. So I have to find out 20 less than what? 20 less than 3 times the larger number. So 3 times the larger number. Now 20 less than that, so minus 20. It has to be in this order. A common mistake is kids will try to go 20 minus 3x. That's wrong. Alright, 20 less than 3 times the larger number, that's 3 times the larger number minus 20. So that is how you get your two equations, except for, wait a minute, not so fast. We have our two equations, but here's something I'm not liking right now. See how I have x's on both sides of the equation? I told you before, anytime you see a variable on both sides of the equation, you need to get rid of one of them right away. So I can either get rid of this x or get rid of or the 3x. Just me personally, I'm going to choose to subtract x from both sides right now. Okay, so that's going to give me y equals 2x minus 20. Alright, now these are the two equations I have to work with, this or this. Now, for the substitution, I could either take this x expression and plug it in here, or I could take this y expression and plug it in over there. It really doesn't matter. It just doesn't matter. I think I'm going to take the x expression. Alright, I'm going to take this stuff and substitute it in for x. Okay, right there. Alright, if I do that, then this equation is going to become y equals 2 parentheses minus 20. And inside the parentheses goes my 2y plus 1, because that is what I am substituting. Alright, if I do a little distributive property right now, bam, bam, then that's going to give me 4y plus 2. Okay, now just doing the rest of it, I've got y equals 4y plus 2 minus 20. Now these are like terms. Let's put those together right away. So that'll be y equals 4y minus 18. Now, again, at this point, I see that I have the same variable on both sides of the equation. We're going to have to get rid of one of these y terms. You don't want to have the same variable on both sides. In this case, even though it's going to give me a negative number, I would probably subtract 4y from both sides. Getting a 0 over here causes students problems, so I'm going to avoid that. So those are gone, and this together makes negative 3y, which is equal to negative 18. And then I shall divide. That's weird. So that's I'm gonna divide by negative 3 on both sides. Okay, so that's gonna give me y equals 6. Okay, so that is one of my answers right there. So I just need to take that y equals 6 and substitute that back in right here to find x. So that's going to give me x equals 2 times 6 plus 1. So that's 12 plus 1. So that's 13. So x equals 13, y equals 6. In other words, because let's not forget this was a word problem, so do not just leave your answers as x and y. You made up those variables. You need to tell me a sentence. Okay? So you can say the two numbers are 13 and 6. Okay? That is how you do that. Let's move on. All right, let's take a look at number 2. Frankie has 22 coins in his pocket, worth a total of $4.75. If Frankie only has dimes and quarters in his pocket, how many of each does he have? All right, this last sentence tells us what our variables need to be. How many of each does he have? So what are we talking about? Dimes and quarters. Now I'm going to go ahead and use D and Q. Let's define our variables right at the beginning. So I'm going to let D equal the number of dimes. All right, how many? That's what we had to find. I'm going to let Q equal the number of quarters. All right, let's make some equations. All right. Frankie has 22 coins in his pocket. You may not realize it, but that is an equation right there. Okay, because he has this many dimes and this many quarters, and altogether that's got to be 22 coins. So that leads me to the following simple little equation. D plus Q has to be 22. Okay, that's the quantity equation. All right, the number of dimes plus the number of quarters should be the total number of coins. Boom. Now the money equation. Okay, the money equation is going to come from this right here. Okay, worth a total of $4.75. Now this is very common. This shows up over and over again, so just get comfortable with the pattern that I'm about to demonstrate for you again. We know dimes, okay? Remember that the value of a dime is, it's 10 cents, okay? So you could think of it as $0.10. You know what I mean? So a dime it's always going to be 10 cents per dime. And in the same way, a quarter has a value of 25 cents. Okay, so when you go to set up an equation that has a total of money, the way you set it up is it's always going to be 10 cents per dime. Okay, so 10 cents times the number of dimes, that gives you the amount of money from dimes, plus 25 cents per quarter. All right, the number of quarters times 25 cents, that should be the total amount of dollars that are going to come from the quarters. Add that all up, and they're telling us that that should equal $4.75. That's supposed to be the total. So these are the two equations, and now it's just a matter of you could either do substitution or elimination to solve this.
So for the substitution method, we need to get one of these variables by itself. So let's just subtract q from both sides. So that's going to give us d is equal to negative q plus 22. Now we are ready for the substitution. So I can take all of this and just substitute it in for d. So that's going to be like this. 0.10 parentheses plus 0.25q is equal to 4.75. And of course in here will be the negative q plus 22. After a little distributive property, that's going to make negative 0.10q plus 2.2 plus 0.25q is equal to 4.75. Looks like we've got some like terms here. The negative 0.10q and the positive 0.25q, those are like terms. If we put those together, that's going to make 0.15q. Alright, plus 2.2 is equal to 4.75. Just combine those like terms, brought that down. Time to subtract 2.2 from both sides and see what we get. So I'm going to bring this down. So that's 0.15q is equal to 2.55. Now, if we divide both sides by 0.15, like so, alright, we get 17. So Q is equal to 17. Alright, that's the number of quarters. Of course, if I want to know the number of dimes, then I will have to take Q and plug it in. So that's going to give me the number of dimes is equal to negative 17 plus 22. So that's going to be 5. The problem is not over until you translate these variable solutions back into words. So we were being asked how many of each type of coin does he have. So don't just leave it as d equals 5 and q equals 17. You have to say there are 17 quarters and 5 dimes. Put it back into a sentence. Alright, so let's move on. So that was number 2. Let's go into number 3. Okay, this is number 3. 4 years ago, Katie was twice as old as Anne was then. In 6 years, Anne will be the same age that Katie is now. How old is each now? So the first thing you have to do is define your variables. This sentence tells you what variables you need. How old is each now? So we're talking about Katie and Anne. So I'm going to define my variables like this. K equals Katie's age now, and A will be Anne's age now. How old is each now? Okay, we need two equations. Let's see if we can pull the first equation from the first sentence. 4 years ago, Katie was. Okay, let's start with that much of it. 4 years ago, Katie was. So look, 4 years ago, and we're talking about Katie's age. So basically in words, and I usually like to start off with a word equation. What they're saying is Katie's, I forgot how to spell Katie for a second. Katie's age 4 years ago. Equals. That's what this part of the sentence ago. Katie was, in other words, Katie's age 4 years ago. Okay? And it was equals twice as old as, so 2 times 2 times as old as Anne was then. So twice Anne's age 4 years ago. Okay, how do I know it's 4 years ago? Because it says then, which is the same as Katie's was 4 years ago. So Anne's age then is also 4 years ago. So I should have highlighted the rest of that. Let me do that now. Twice as old as Anne was then. So this orange sentence becomes this word sentence. Now, what's an expression for Katie's age 4 years ago? Well, that would be Katie's age now minus 4. What's an expression for Anne's age 4 years ago? Well, that would be Anne's age now minus 4. So this is the equation that comes from this orange highlighted sentence. I usually like to simplify this just a little bit more by doing the distributive property. So this is going to go ahead and give me 2a minus 8. And I could simplify a little bit more if I wanted to, but I'm going to hold off on that for now. Alright, now that's one equation right there. Now I need another equation to be able to do the problem. So let's see if I can get another equation from the next sentence. In 6 years, Anne will be, okay, let's talk about that for a second. Alright, I'm going to do this as another word sentence. In 6 years, Anne will be. So suddenly we find ourselves talking about Anne's age. Man, I need more space. I'll put it down here. We're talking about now Anne's age. Okay, because it says Anne will be. And it's Anne's age in 6 years. Okay, that's what this sentence is talking about at first. In 6 years, Anne will be. So we're talking about Anne's age in 6 years. Now let's find out what happens. It will be the same age that Katie is now. Sound familiar? Now. Okay, so hopefully I emphasize that enough. Okay, it will be, oh, that's not the color I meant. It's awfully dark. The same age that Katie is now. So back in equation mode, so Anne's age in 6 years should equal Katie's age now. Okay, that's my word equation. Now turning that into a regular equation. Anne's age in 6 years. Well, that'll be Anne's age now plus 6. Okay, Katie's age now, well, that's K. Alright, that's why we defined our variables right from the beginning. K equals Katie's age now. So just K. Alright, so these are the two equations that we are going to deal with. I once again would do substitution. This K is already by itself. So it's ready for substitution. So I just need to go ahead and take this stuff and substitute it for K right there. So that's why over here I'm going to have A plus 6. Alright, because I just substituted that. And then the rest of it, minus 4. Like that. I'm combining these like terms here, so I'm going to wind up with A plus 2 equals 2A minus 8. I have to solve this. I see I have the same variable on both sides of the equation. Whenever that happens, you need to get rid of one of them. So I'm going to subtract A from both sides. So that's going to leave me with 2 equals A minus 8. Alright, let's add 8 to both sides. So that gives me that A is 10. Okay, so Anne is 10 years old. That's part of what I need to know. Now I still need to know Katie's age, so I'm going to do another substitution. Okay, right there. So that's going to give me 10 plus 6 is equal to K. So K is equal to 16. Alright, so once again, before you consider yourself finished, write an answer sentence. So there's your final answer. Katie is 16 years old and Anne is 10 years old. Alright, so that is a typical problem. So let's move on. I think that was number 3. This is number 4. Alright, for some reason my numbers keep moving to strange places in the document. Alright, the price of a sweater is $5 less than twice the price of a shirt. If 4 sweaters and 3 shirts cost $200, find the price of each shirt and each sweater. Alright, that last sentence tells us what the variables need to be. Alright, we need to find the price of each shirt and each sweater. That's what the variables need to be. Okay, shirt and sweater. So they both start with S, so that's not going to really help me out. So you know what? I'm just going to use X and Y. Alright, so I'm going to let X be the price of a shirt. Alright, be very specific. Don't just say X equals shirt and Y equals sweater. It's the price of a shirt. Please be specific. The price of a shirt. And I'm going to let Y be the price of a sweater. Okay, that's called defining your variables, and that is your first step. Okay, now let's make some equations. Alright, first equation should come from this first sentence. The price of a sweater is $5 less than twice the price of a shirt. Okay, let's see if we can break that down. Okay, the price of a sweater, that's going to be Y, price of a sweater. So I'm going to start off with Y. Okay, is, so I'm going to put equals, $5 less than. Now I'm not going to put a big old 5 here. Anytime you do less than, you wind up subtracting that on the end. So there's going to be a minus 5 like on the end of whatever they say next. So stay tuned. $5 less than twice the price of a shirt. Okay, I heard him say twice the price of a shirt. Well, X is the price of a shirt, $5 less, stick it on the end. Do not put 5 minus 2x. That is wrong. It's got to be 2x minus 5. Always put that subtracting on the end. So that's our first equation. Second equation. Okay, 4 sweaters and 3 shirts cost $200. Okay, let's make an equation out of that. 4 sweaters, okay, that's Y, and 3 shirts. Okay, so it's 3x. And that's going to equal $200. Okay, all right, 4 times the price of a single sweater. That's the amount that I'm paying for sweaters. This will be the amount that I'm paying for shirts. Total of 200. So another good equation. So that's it. I needed my 2 equations and I got them. The rest is easy. By the way, I apologize for the tired sound of my voice. I just did not get a lot of sleep last night, and I guess I was yelling or something. Anyway, what was I yelling about? You don't need to know. That's not part of the lesson. Mind your business. But pay attention. So I'm probably boring you to death because my voice is like, then you do 4 times, and you're like, I'm falling asleep. 4 times parentheses plus 3x equals 200. Always use parentheses when you do your substitution. 2x minus 5. Okay, so there you go. Time to do a little distributive property, like you do. So that's going to be 8x minus 20. And that's going to be plus 3x equals 200. You know what? Some of you guys are waiting for this video. Okay, my good student Tyler, he was waiting for me to hurry up and finish this video. And, that's very good. Whoa. But the reason why I have not been around to make this video today is because I've been at the car dealership. These terms go together, so that's going to be 11x. Yeah, like a week before school started, this guy hit me from behind. I'm pulling up to a red light and just bam! I don't think he even hit his brakes. Hit me at full speed. And kids, that is why you never text and drive. I don't have any proof that he was texting other than the smashed up rear end of my vehicle. Alright, so this is 220. Yeah, nobody was hurt. I'm sure he was like stiff for a couple of days. His airbag definitely deployed in his face, but he seemed okay. I was totally fine, well-built cars, those Hondas that I was driving. So X is 20. Alright, we still need to find Y. So of course we're going to take that and plug it back in. Alright, my poor little Honda Civic. I loved that car, man. It wasn't much, but it was mine. And now it's gone. It was totaled. Let's see, so once I plug this 20 in there, it's going to be like that. Okay, so you can see what's happening here. So this is 40 minus 5. plus y equals 35. Alright, you want to see what the car looked like after I got hit? Here, I'll show you a picture. Hang on. Bam! Literally bam. I mean, I got rocked by this dude. Yeah, that was totaled. It was a total loss. Anyway, back to the math. We made up these variables, x's and y's. So it's more important than ever to go back and put this as a sentence to get the meaning back. So remember that x was the price of a shirt and y was the price of a sweater. So here's the answer in words. Yeah, shirts cost $20 and sweaters cost $35. Again, do not leave your answers as just x equals 20 and y equals 35. You must turn it back into a sentence. Alright, that's another problem down. Let's see what's next. Yeah, anyway, the end of that story was I had to buy another car. Yeah, I'm going to get some money back from the insurance company, but it's never enough to replace what you lost. So, it was not a great day for Mr. Burton. Okay, Greg is a star player on the basketball team. In one game, he scored 20 points, made up of 2-point baskets and 3-point baskets. If Greg made a total of 9 baskets, how many of each type did he make? That last sentence tells you what your variables need to be. How many of each type did he make? We had 2-point baskets and 3-point baskets. I'm sorry. I'm yawning now. It's definitely going to put all of you to sleep. I'm not seeing any obvious letters to use to differentiate between these two, so I think once again I'm going to use x and y. So all the more important to define your variables. So I'm going to let x equal, see how many of each type. So x is going to be the number of 2-point baskets. Alright, man, I write slow. Y is going to be the number of 3-point baskets. Alright, let's get some equations going. Let's see. Greg is a star player, blah, blah, blah. No equation there. In one game, he scored 20 points, made up of 2-point baskets and 3-point baskets. I'm betting there's an equation in there somewhere. 20 points, made up of 2-point baskets and 3-point baskets. Okay. Alright, here's the equation that would go with that. Alright, we're talking about points now. Well, of course, the amount of points, there's 2 points for every 2-point basket, right? So he's going to get 2 points for every 2-point basket, which we're using x to represent how many of those there were, plus he's going to get 3 points for every 3-point basket, and we're using y for that. So 2 points for every one of these, 3 points for every one of those is going to equal a total of 20 points. Okay, so there's our first equation. Now our second equation is hidden there in the second sentence. He made a total of 9 baskets. Okay? So if x is the number of 2-pointers and y is the number of 3-pointers, if altogether he made 9 baskets, then that just means, what color do I use for this? Oh yeah. That means x plus y must equal 9. The number of 2-pointers plus the number of 3-pointers has got to add up to 9, because that's the total baskets that he made. Alright, so there it is. These are the 2 equations that we are in fact dealing with. Alright, I've done substitution for almost all these problems, so This one is a decent one for elimination. So even though I could easily get x by itself and substitute again, just for the sake of variety and teaching purposes, I'm going to go ahead and do this one by the elimination method. Okay, so for elimination method, everything really kind of needs to be lined up. I thought I would cheat and move it, but I better just redo it. Okay, so I've got x plus y equals 9. For elimination method, your x's need to be lined up, your y's need to be lined up, your equal signs should be lined up, and your constants, like 20 and 9, those should be all lined up. Now, of course, for the elimination method, I need opposites that cancel. So this is a positive 2x, so I'd love to make this a negative 2x. Negative ghostwriter. So if I multiply the bottom equation by negative 2, that's going to make this a negative 2x. Of course, I have to do the whole equation, so, deal with it. So this is going to be negative 2x minus 2y is equal to negative 18. Don't forget to multiply the 9 as well. Some kids forget to do that. Now the top equation did not change, so I'm just going to bring it over as is. Okay, so if I just bring that over, so I've got my 2x plus 3y is equal to 20. Notice I've got my opposites, they cancel right here. So these are in fact going to cancel out just like we wanted. 3y minus 2y, that's just y. 20 minus 18, that's 2. Okay, so y is equal to 2. That's excellent. So, that's one of my answers right there. Now I'm going to do that substitution thing. Yeah, so even in elimination method, there's a little bit of substitution. I have y now, so I'm going to take that. I could have plugged it in up here if I wanted to, but this seems simpler. Alright, so I'm just using the green part. I'm not using the negative 2 or anything. So this is going to become then x plus 2 equals 9. Alright, plugging it back into the original green equation. Subtracting 2 from both sides, I get x equals 7. Alright, again, x and y, we made that up. Alright, we need to answer the question in words. This is a word problem. How many of each type did he make? Let's see. X is 2 pointers and y is 3 pointers. So, in words, it would sound like this. So your final answer would sound like this. He made 7 2-pointers and 2 3-pointers. Alrighty then. I think we have one more problem left in this assignment. And then we'll be done. Okay, let's go through the process one more time. 5 years ago, Tom was 1/3 as old as his father was then. In 5 years, Tom will be half as old as his father at that time. Find their ages now. Alright, my daughter Kayla is going to help me with this. This problem is a really tough one, so this will be a tag team effort. Let's see what we have going on here. What is she doing 5 years ago? Alright, see, this is Kayla. Kayla's doing this writing. So you can see her thought process. So you notice she had a small mistake there with the t plus 5. But she caught it, and she decided to go with t minus 5. Alright, so this is Kayla. I'm just standing here. Kayla's actually doing all the writing. Can you explain what you're doing?
I'm just writing equations for all of these right now.
Tell us where this equation is coming from.
Well, if
Here, let me just give you the headphones. You can't hear anything. Alright, go ahead.
Well, if 5 years ago Tom was Tom was 1/3 as old as his father was then say Tom is T and his father's F, then T minus 5 would be Tom's age 5 years ago, and F minus 5 would be his father's age 5 years ago.
Okay, makes a lot of sense.
So then, in 5 years, Tom will be half as old as his father is at the time, so T plus 5 will have to equal half of F plus 5.
Okay, so that's your two equations. These are ugly, ugly, ugly looking equations. Do you
Yeah.
think you have the ability to solve them?
Probably.
Alright, let me know if you get stuck.
Okay.
So I have hints I can give you if you need them. Let's see how Squirt does flying solo. Okay, see what she did there? She rocked a little distributive property.
Mhm.
Could you maybe like make some arrows or something, kind of showing them how you distributized that mess? Okay, 1/2 times 5 is 2.5, so she went ahead with the decimals, which is fine. Okay, you might have lost somebody just then. Tell them where the negative 2.5 came from.
2.5 minus 5.
Okay, very well. Carry on. Wait, tell them what you're doing. I think an arrow might be in order.
I'm plugging in this equation for that T.
Okay, just want to make sure you're not missing it. Kayla is magical, not unlike a unicorn. Okay, oh, so there go the arrows, I'm just going to say. Alright, very good. So 1/3 times 5 is 5/3. If you're not sure about that, you guys at home, you've got your TI-30 XS
Multi-view.
and you can double check that that's the case. Where'd that 7.5 come from?
Negative 5 plus negative 2.5.
Alright, very good, splendid. Alright, do me a favor. Let's, on this next step, because my kids that are listening to this video, they're not comfortable with fractions, so let's do this on the multi-view. No, this
Okay.
is fine what you're doing. Let's see. Let me just pause this to pull up the calculator. Okay, so we fired up the calculator. Okay, so just to refresh your memory, Kayla's got this whole 1/2 F, and she's trying to subtract 1/3 F. But you can do this on the TI-30 XS.
Multi-view.
Yeah, you guys think Kayla's heard that a few times? Wait, do it as fractions, is what I'm saying. Since the calculator can totally handle it. And because I don't want any rounding or anything like that.
Okay. So it's 3/2.
Wait, look back at the paper. Switch back to the Word document. Do you really mean to...
Oh. Oops.
Do you guys see the mistake she made? Where I paused for a second. Well, I guess they can't see what I'm pointing at. Did you guys see what she did wrong? What did you do wrong?
I divided instead of subtracting.
Alright. Okay.
This is really awkward. There's a decimal there and a fraction that. Whatever.
Let's see how the multi-view handles it. Yeah, let's just put that in the old multi-view. Alright, so we have -5. Well, I guess they'll see when you type it.
-5/3 plus 7.5.
Alright, -5/3 plus 7.5. Okay, that's ugly, but the calculator switched it back to a fraction, so we're good again. Oh wait, some of these kids are new to the calculator.
Oh.
Notice the red button that's highlighted there, the toggle. Give me that, man. The toggle. Look. The toggle. He's not relinquishing control. That double arrow there, yeah, switches. Hit it a couple times. Decimal, fraction. Decimal, fraction. So you can always get your fraction when you need it.
This isn't going anywhere.
Alright, let's get back to the paper. So 35/6. Okay, she's multiplying by 6 to get rid of the denominator. So F equals 35. Okay, alright, I'm grabbing the pen from Kayla just to make space for her final calculations, if I may be so bold. So I know what she's about to do next. And I'm just going to move this down a bit so she has space. Okay, here's your pen back. Alright, what will you do next? So we have F equals 35, so put a little box around that. So it's like, yay, an answer. Yeah, I like that. Nice touch, nice touch.
So now I'm just gonna plug this into here to find what Tom's age is.
Okay. Alright, just for fun, type that whole thing into the multi-view so we can because we're out of space anyway. Can you remember it all?
1/2 of 35 minus 2.5.
Yeah, your memory is better than mine.
That's why you make me memorize the garage code, the pool code, Dad.
Fact. Early onset Alzheimer's. Not a laughing matter.
Unless it's you.
Okay, bam. So T is 15. Now we're running out of space, but we really want to write this answer in words. Maybe we can squeeze it in. You can squeeze in. I'm going to pause because it takes time to write a sentence. So Kayla's going to finish writing the answer in the pause. Kabam! I always like to say kabam.
Okay.
Alrighty.
Good to know.
Yeah, so here, let's point at it. Up in this area, you can see her final answer. Tom is 15 years old now. His father is 35. Alright, so I think we can all agree that was a great job done by Kayla. Guys, let's see, which class?
if you're in my second period class, this is the same problem that we did. This was our warm-up. So I actually did this problem in class. I did it slightly differently. When I did it, I multiplied to get rid of all the fractions and everything. So I think it's good to see how Kayla did it, because maybe some of you would find it easier to do it the way Kayla did it. Alright, that is the end of this lesson. Hope you enjoyed. Let's give a special shout out to my daughter for helping us out with that last problem. My voice was tired, and you guys are probably tired of hearing my voice, so it gave you a break from blah blah blah. Alright, I will see you guys on the next video.